Good morning. Welcome to Superfest 2022. It's our first one back in a few years, and we have a nice slate of presentations here today, and we're hoping that everyone enjoys this. We're also doing this live on YouTube this year, so it's the first time back for that. And I'll have the question mic here. Well, if you have a question, please get a hold of me. I'll come over and ask, so you can ask questions so the people watching online can see. I don't want to hold it up here too much. We have Dr. Jack here from COMPACtenna, who's has a very interesting product here that I think everybody will find interesting here. So Jack, if you want to go ahead.
Good morning, everybody. Thank you for coming. This is all about small antennas, yet still high performing. That's VHF and UHF, 2 meter 440, but also HF even. And the original idea was to have a small antenna high performing on your vehicle so you could get in and out of parking garages. And to do that, I had to come up with a different approach, an entirely different approach to antenna design. And this is a patented design. So then it became so popular that people wanted it also for base station. So I designed the optimized counterpoise. I don't know if you've seen the QST review in August, just a couple months ago, but it was really good for mobile base station. Even driving along and operating satellites from the vehicle, right? Not having to have a beam and pointing up there. It's all about how this is different. So, yeah, they talked to the International Space Station, and then they even talked through Oscar satellites back to Earth while driving. This is a two-part presentation, and some of the slides you may need to go back to YouTube and look at afterwards because I don't want to take up too much time. And then we'll have some question and answers afterwards, so I'll flick through some of the slides. It's two parts, starts with science, and then goes to the models, which we're all interested in. Let me just tell you in a nutshell how it's different, okay? 1, 2, 3. That's the thing. Number one, substantially reduce the losses that you have with matching networks of standard antenna technology. Number two, what you want to do is when you shorten antenna, when you shrink the antenna, don't just have a so-so electric field and virtually no magnetic field. Don't have a so-so magnetic field and virtually no electric field, like small loops. Have a substantial, both electric and magnetic near field in a SORT antenna. Okay, that's number two. And number three, incorporate diversity gain. It's so important. If you're on a 200-foot tower, put the biggest antenna you can with the maximum single polarized gain that you can. Absolutely. But how many of us are like that, right? Especially in the mobile. But, so you want elliptical polarization, you want phase diversity, so that you take the flutter and you reduce it, because that's all about your communications on planet Earth. Both in the mobile and the base station. If you're on you want a small HOA, you want a nice antenna on the chimney mount or even the attic, but you want stabilization. You want to get into more of the repeaters. Some of them that are weak, they're just not quite there. This captures that. Okay, so those are the three things. All right, now before jumping right into the video, how about you see what's inside this thing? Now I'm looking around for a minute because I want to see who's here. Make sure there are no children. Okay. We're all a child. Okay, so there you go. Is there somebody that can read the front of this thing? Somebody can just maybe in the audience read what does it say on the front there?
More snake oil.
Now with 20% more snake oil. And I buy the best snake oil that you can get. Okay, I'm just kidding. It's not snake oil. All right, let's go ahead with the presentation. Thank you. Let's find out what it really looks like inside. All right. Oops. That was... Okay. Introduction. I'm not going to read every slide because there isn't time. You could go back later. But again, 2 meters, 220, 440, even 20 meters. Small antenna, small ground plane. Notice the antenna's at the corner of the vehicle. There are 4 corners. There's only one center. There are 4 corners, okay? So it's actually a good thing. It uses the downward metal of the vehicle as a counterpoise, okay? You can ask me anything later on more detail. That's just general. HF, what's good is a 20-inch, 20-meter antenna? Yeah, it really works. Look at the YouTube videos of other people that use it. And what good is it if you need long radials? This is also entirely different. Small counterpoise, a sheet of metal, extension of aluminum foil. You can even put mulch over it. In an attic, you can put mines in the attic like that. It capacitively couples to planet Earth, just like a magnet mount for your 2-meter antenna. Very well couples to your vehicle. And I have the formulas on there, which we won't go over today, but it does. What's convenient about the small side? It's obviously for the vehicle, getting in and out of your own garage, getting in and out of hospital parking garages, et cetera, et cetera. For the home, we need stealth. You know, either you know, our family doesn't want something big up there, or the neighbors don't, or you're not even allowed to based on the HOA. This little antenna, the 9-inch, 2-meter, 440 plus, 2M 440 plus on the compact counterpoise that I perfected, it's very stealth. It even works in the attic, but on a chimney mount or a pole in the backyard, I mean, it's so small, yet so high performing. Like I said, science and technology, I already said those things, and then the models. All right. Kind of an overview of antennas. You know, we all look at SWR, and we look at gain, you know. Well, gain is in a single polarization in the far field, particularly, you know, on either a test range. Been there, done that many, many, many times, you know. But that's not all there is. There's much more to it. Let me just say this about gain. I'm going to summarize. You can read that. But say you're in a valley, okay? And you're on a mobile or you're on a base station. And you want to communicate with somebody on the other side of the hill, all right? Do you want to have an 8-foot super high gain antenna or a 15-foot super high gain antenna, or are you better off with a quarter wave? In that situation, you're actually better off with the quarter wave. The high gain antenna is just going to slam the signal into the side of the hill. With the broad elevation coordinate pattern of the quarter wave, you get some signal up and diffract over the hill. Of course, there's limitations, but that is one example of how you have to look at the big picture in the real world obstructed environment that we're in. So you have antenna efficiency. You can have a lot of gain in one particular pattern, regardless if it's directional or omnidirectional. But if only a certain amount of the power is actually getting out, you have a low efficiency antenna, all right? So that's important to realize, the efficiency. What about loss? There's all kinds of things that occur in the matching circuit I mentioned, the radome, the dielectric that's used. All of these things go into it, and then there's diversity gain. And diversity gain can be spatial diversity, up, down, or left, right. You know, you're driving along, you're listening to a repeater, an FM radio station. You stop at the light, the signal goes away. What do? You creep forward a couple of feet, and there it is again. That's diversity gain if you have an antenna that incorporates that. Polarization diversity, both in the ionosphere, but very much so inside, outside, buildings. Polarization keeps switching. That's part of what the flutter is all about that you get. Irritating, even dangerous. If you can create a circular elliptical polarization, you stabilize that signal. So even if your very peak signal when you're at a hilltop is slightly less, it isn't with the 9-inch, but slightly less, your effective overall performance gain, your range, your obstructed range is actually greater because you have a stabilized signal. All right. Phase diversity I'll talk about. All of that comes into the new term mean effective gain. Okay? That's what MEG is all about, taking all that into consideration. And then there's noise reduction. We'll see that with a guy that did a review. He put it on his Tesla vehicle. He couldn't even operate a 2-meter repeater a couple miles away, even when the engine was turned off because of all the electrical noise. Magnetic field antennas in the near field reduce, like small loops, the noise, but so does this, because it has substantial proportion of the magnetic and electric field. This basically says the same thing. All right, so what's the standard way of doing things? All right, well, a shortened monopole, basically you have a real problem. All right, you have two real problems. One of the problem is it becomes an antenna that has capacitance. So you use coils, loading coils, tuning coils, combination. You use them in order to have it in series so that you eliminate that capacitance. Okay, all right. I'm saying this as short as I can, and then you have another problem. You have resistance. When you bring the hot voltage point of an antenna down near the ground plane, plus, minus, minus, plus, you reduce the resistance component of the antenna dramatically. Again, there's resistance, capacitance, and inductance. You reduce it dramatically. You have to then create a matching circuit. So matching circuits are similar to this kind of thing right here. So here's your capacitance. You put your inductance to ground, and you increase then the resistance back up. Unfortunately, a lot of losses occur typically in that. Sometimes you do everything, as you can see up here. Everything but the kitchen sink is thrown in there. Okay, I could talk a lot about that, but I won't. It actually gets much more complicated than this. It's this over here. It's actually more like this here, which is very similar to this, which is feed a circuit equivalent. So, but of course it is. An antenna is basically a split feed. So, okay, enough of that. So what happens with the standard technology when you shorten it and you do all these things? You decrease your bandwidth, you decrease your gain, and you have inefficiencies. You have electric-magnetic field waste as well, because yeah, these coils and capacitors, yeah, kind of like a tank circuit, yeah, they create a resonator. I talk about the magnetic field resonator. Yeah, they do radiate some, not much, and whatever they are is basically grounded out. So you got to fix that. You got to really get out of the box and do something different. And this is completely different right here. This shows you all the different capacitance that goes on. It's not just with a coil, standard coil that goes down to ground. It's also intertwined capacitance. This has a tremendous intertwined capacitance by using sheet of metal. Get away from the wire. You got to use sheets, people. You got to use sheets. It's essentially an extended monofiller Tesla-like coil. You have tremendous intertwined capacitance. You have increased inductance relative to the length versus a helical, and it's in parallel. It's in parallel. So not only now do you have matching that occurs, you've also got diverse magnetic fields here, and you have phase shifting along the coil itself for phase diversity. You have all of these things. And actually the antenna inside's a little bit more complex than that, but that's the basic. That's from the patent. So you wind up doing those three things that I mentioned. One, reduce the loss from separate matching systems incorporated into the antenna. Number two, the strong magnetic field and component in addition to the electric field, and lastly, diverse near field electric and magnetic fields. So elliptical polarization that's just an example of it there. Phase diversity is an important thing because we're super multipath environment. You're driving around, and really there's typically this is very rough, but 4 to 5 different signals in the multipath that are actually usable. They can completely cancel out, and that's where you lose the signal completely. If you have phase diversity along the coil, and you have some of that is not entirely in phase, not entirely out of phase, but you get summation. So at the end of the day, rather than having signal that goes boom, 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 20 dB differentials, and you completely lose it in the drops, you now have a smoothening of the effect. And Wi-Fi systems know this. They just do it different. They use 2 antennas, 2 small antennas, 3 antennas, 4 antennas. Look at your Wi-Fi routers. That's how they get increased range without increasing gain. In fact, they decrease gain. Okay, digging a little bit deeper. Let me see how I'm doing for time here. Oh, that's not too bad. All right. This is a famous a photo of Niels Bohr and Einstein. And Einstein was all about the maximum speed being the speed of light. And Niels Bohr says, well, it looks like with quantum mechanics, there's actually some near immediacy of interaction, far beyond the speed of light. Okay, that's interesting. Does that apply to antennas at all? Yes, it does. Very much so. When you look at an antenna, when you're close to the antenna, and here's a dipole, here's a short monopole, here's a magnetic loop, here's this new technology. You have near field, midfield, far field, defined by that formula, about 2 wavelengths to 10 wavelengths and beyond. The near field and the far field are entirely different. The near field is very much about what virtual photons are. Well, electromagnetic field is gauge bosons, which is photon. That's the photon going at the speed of light. But here in the near field, your interactions in the electric and the magnetic field, current and electric portions, have near immediacy. That's the quantum physics of things that Niels Bohr talks about when it comes to antennas. So what happens when you shorten like a full-wave dipole? What happens here? Oh, you really get reduced both magnetic field as well as reduced electric field. It's not a great thing. The electric and magnetic near field is in essence summates to the far field. All right, so if you have a strong electric and strong magnetic, you get a super strong far field. If you got a weak, magnetic and a weak electric near field, not so good in the far field. All right, now what about magnetic loop? Well, predominance of the magnetic near field. Still, it's dBs down quite a bit, but it works because it reduces noise. That's the main thing. And then you put a preamp on it to bring the signal back up. But the electric field is virtually non-existent in the near field. What about COMPACtenna? Substantial for size, both electric and magnetic field and diversity of those fields. That's key. This is just another way of looking at the same thing here. And this is just a hand-done drawing to give you an idea of, let's say, a longer antenna on your vehicle or at your base station, but less than 200 feet, which most of us are, Yeah, look, at certain peaks, hilltopping, you'll have a slightly higher signal because when your line of sight, and I'm not going to go into the specifics of atmospheric fluctuations and all of that because they are really there, but notwithstanding that, you have a slightly higher signal. So if you want to be the big man behind the mic and you're driving out there and you're on the highway, you get off the highway, you see a hilltop, and you key up and say, I made it. Yeah, but what did you do for the last 20 miles? Oh, it was non-existent. Wouldn't it be better if you had a reliable range increase? So even though the hilltopping is slightly less, look at the difference. The high gain antenna drops, flutters. Here you stabilize it. It's very important. Oh, we're already at the models. I could pause, but let's go with the models. Okay, so there's 2 groupings. There's VHF, UHF, and there's HF. The VHF, UHF, you can see it there. The QST review in August was about this one, the 9-inch optimized gain. I'll tell you what, with that one, even at the hilltops, you're up against the long antennas, and you can see that on videos on my website. Other people independently testing it. Listen, there are base station adapter kits out there, but none of them are optimized for everything. And I'll show a slide on that later. You know, you've got SWR, you got pattern, elevation coordinate pattern, and the ones that are sold out there, well, they're on VHF, 220, 440. They're good here, not so good there. You needed one that was good everywhere. And oh, by the way, made in the USA like everything. HF, 20-inch antenna for 20 meters, are you kidding? It works. And you don't need a large ground plane. You're not using the long radios like I talked about. So VHF, UHF models, again, they're at the corner. There are many ways to do that. There's magnet mounts, there's lip mounts, there's all kinds of mounts now, available. Which model is for you? Well, you can look at this more later. It all depends on your characteristics. If you want 220, well, then if you got to have 220, that one has it. If you want the best in 2 meter 440 and 9 inches and too tall to fit through the garage and mount it on your vehicle, then that's the way to go. There's also scanner, land mobile radio. That's really good. Through the years, I have relationships with Secret Service, Homeland Security, government. Actually, prior patents of mine, the antennas are in Washington, D.C., securing us all the time. So they said, hey, can you take this new technology and apply it for the application where we really need a short antenna and also operate VHF? And that's where I came with the land mobile radio antenna. There's a lot of technology in there. What do other people say? Bob Grove, fantastic guy. He used to be the Monitoring Times, now in the Spectrum Monitor. He says, what does he say about the flutter? Yeah, the signal flutter reduction was true. Scott Roberts, KB3 CBC on the 7.5-inch tri-band model. It's only $99. I've never increased prices. Noise floor was down. Signals evenly distributed. Etc. Minimal fading. This is the Tesla vehicle I told you about. That's pretty significant because we're getting more and more hybrid vehicles, electric vehicles. They produce a lot of electric noise. Did you ever notice that a Tesla vehicle does not have an AM radio in it? It never will. It's impossible. Well, it's not impossible. You could create a noise reduction circuit good enough, but it'd be really big and really expensive. So it's not there. This is the review in QST, reprinted by permission. Again, mobile, base station, and even using it for satellite communication, which they thought was really cool. It makes sense, right? Because most people say, well, see, this is another paradigm shift. If you have an omnidirectional antenna, how are you going to operate the satellites? Well, you get a really long one in high gain, and you're a little better at the horizon then, right? But the second it comes above the horizon, it's gone. So you have to have a beam and aim it up there. Or you have to have some type of an elliptical polarization that aims it straight up, but then you need another one for over there. This does it all. This has a broad elevation coordinate pattern that fills in that null directly up that the others does, elliptical polarization that reduces the Faraday polarization shift in the ionosphere and stabilizes your signal. It works. And that's what they said right there. They talked at the International Space Station while driving, and also Oscar satellites back down to Earth. It's different. It's definitely different, and it's fun. So there's the dual band, 7.5-inch antenna. That's as short as it gets. Tri-band, if you need the 220, just $10 more. And what did I do there? I must have... Thank you so much, and thanks for all you did here. It's great. This is the Plus, the one reviewed in the QST. it was great to hear the 7.5-inch antenna and people saying, yeah, 10 miles, 15, 20 miles away from the repeater and the hilly and the buildings and all of that. Yeah, it's fantastic, But sometimes I'll switch to my really long antenna if I go out in the distance and whatnot. I wanted to fix that, so I made the 9-inch. You say, wait a minute, you have a dB and a half gain more from 1.5 inches? That's impossible. I mean, normally we think in terms of multiple quarter wavelength sections, right? Or collinear 5/8 or these kind of things. No, it's a logarithmic curve. It's an inverse of exponential curve on the loss when you're in that sector of length. Okay? All right. Land mobile radio I talked about. Scan 3. That's my vehicle, by the way. It's on the parking lot. I like dedicated radios for dedicated antennas. Sure, you can get diplexers and triplexers and all of that kind of thing, and yeah, that's okay. Or you have radios that do everything, but I have a Scan 3 on the one and the 2M440 Plus on the other corner. But yeah, the scanner antenna, boy, you want to pick things up, civilian, commercial, government, digital and analog, land and satellite communications. It's really a good mobile and base station on that counterpoise antenna. How do you mount them? They're NMO style, okay? How do you mount them? Well, there's a lot of ways to mount them. Again, at the corner, we talked about that. What type of mounts? Okay, magnet mounts. Does it work in a magnet mount? Yeah, I'll show you a slide in a moment. We won't go through the formulas. It's on my site, and it'll be on this YouTube video. You can pause it and look at it. There is very good capacitive coupling between a magnet mount, okay? There is. Get that away that magnet mounts are no good. Sure, drill a hole through your roof. Use a bracket mount, the screws into the side of the vehicle. Yeah, maybe there's a slight ultimate there, but not much. There's really good capacitive coupling. And even the clamp-on mounts that are available, very commonly used these days. There's enough capacitive coupling there, even without the screws. Remember, there's a difference between electrical ground and electromagnetic ground, okay? All right, but they work. What else do we have here? Through-hole mounts, bracket mounts, universal mounts, all of those. Here's one on a pickup truck. There's the formulas that show you the capacitive coupling is very good, even up into HF a little bit. This is the compact counterpoise. The point of this slide is what I said here. When you look at a base station adapter kit, the lengths, the dimensions here, the angle, you want to check mark all of these things. But if you look at a base station adapter kit with some radios sticking straight out, you're going to get some checks and you're going to get some X's. You're not going to get them all checked on all those bands. That's for sure. Oh, this is just somebody that did a review from New York City. He says, I'm in a total obstructed environment, and yet even with 5 to 10 watts, I'm getting into repeaters all around. And he says it's the easiest base station setup he ever had. The microbeam. So, there are some enthusiasts out there. I'm one, and we've used very long beam antennas and whatnot, but, Yankees and whatnot, not very practical for a lot of people. You certainly can't bring it up into the attic installed, and if you assembled, and if you go up into the attic, it's pretty hot and uncomfortable up there to make one. And outside, they're very big and unsightly. So I took this technology and created a microbeam. Much more performance than expected for size. It's so small, you can generally take it fully assembled and bring it up into your attic. If you use it outside, it's small. Small is what people want. Great for HOAs. No tuning. This is so important. No tuning necessary. You can even use a small TV antenna router, or Yaesu makes a low-price one. MFJ makes a low-price one. It's small. It has the technology. It has the counterpoise. Then it has a full wave loop reflector for 440 and for 2 meters. Lot of testing and analysis to get that optimized maximally. I guess as small as it is for outside, to get it small enough to get it up into a standard attic opening, that was a challenge. No tuning. Oh, no tuning. Yeah, That's so important. You have other beam antennas out there. You got to turn to 2-meter section, then back to the 440, back and forth all of this time. Some of them, says enough of using essentially a diplexer up there for 2 bands. Let's use 2 coaxes. Let's have separate feeds. 1 feed, 0 tuning. It's done. As long as you don't have it like right next to an aluminum siding house, it's done. Even in an attic. Oh, it's Ham Bandit. This is a delightful gentleman. This thing is awesome. He did a YouTube review on the early model. So HF, to finish up, we have HF. HF, 20 meters, CB, shortwave. You can put mulch over this metal and aluminum foil. It's very easy. Again, you don't need all those long radials because this is, again, different. You're not using quarter wave radials all around, 56 of them, whatever, at different lengths. In order to create your tuned counterpoise, you're using sheets. Again, you get away from wires, you use sheets of metal that capacitively couple to planet Earth, just like to groundwater and whatnot. Similar to the magnet mount on a vehicle that couples to the vehicle itself. This is actually a photo of my attic, the 20-meter antenna. I have a ball with it. There are videos linked on YouTube from my site that show other people doing it. And then on the vehicle. And people ask me, what about the vehicle? I don't officially recommend it for a moving vehicle. Surely, POTA, park on the air, campgrounds, whatever, because I can't control the mounts that they're going to use. So it's all a matter of that. But if you use a really good mount, like a ball mount or a really solid through the roof mount kind of thing, a really good bracket mount, well, of course it's going to be okay. But I had to put that disclaimer because, as a manufacturer, you have to do that. Remember the drawing I showed you of the decreased flutter with VHF, UHF? Due to the multipath in the obstructed world we live in? This is analogous in the ionosphere fluctuations that you get. Look what happens when you take, this is a 20-meter, 17-foot tall monopole. This was actually done by a major defense contractor, and they sent me back, and he says, look at this. I says, yes, exactly, that's what I've been saying. They says, of course you get the higher peaks, 22 dB versus 13 dB, 14 dB versus 7.5, absolutely. Yet it doesn't have the same direct gain in a single polarization, but the ionosphere has flip-flops. So what happens when the signal went down? This is what they noticed. The 1.5, which is almost unusable, with the full size was 3 dB, and it was usable. So they were getting stabilization in what they were using it for, which is also not to be disclosed. And the 8 dB, 10 dB, 9 dB was 9, 7, 8. Look at one more thing. When you're right down there on the noise floor, where it's like virtually non-existent, look what happens here. It's actually greater. It's a different way of thinking, but not entirely. Like I say, the Wi-Fi industry, cell phone industry, they do it. They just use multiple antennas rather than a single antenna with diversity. There's the 20-meter one, there we have it in the attic in the vehicle, and that's basically it. This was all developed originally to, we all really would like to do something in life that particularly helps mankind in one way or another, and there's a multitude of ways of doing that, sometimes just in your interaction day to day with people. But in my case, it was to develop a distinctly different technology, one so different that you get the snake oil comments. Of course, they don't get many of those anymore because enough people have actually reviewed it and says, yeah, it actually works.